You know, for literally thousands of years, people have dreamed of turning cheap metals like lead into pure gold. It was the stuff of legend, of magic. But lately, you might have seen some headlines that sound, well, a lot like those ancient dreams. Headlines claiming scientists have finally cracked the code. So today, we're going to dig in and separate the incredible science from the internet hype.
So this all kind of blew up with posts just like this one. The idea that someone, somewhere, could just print gold in a laboratory? I mean, that sent shockwaves through social media and finance forums. It sounds like a total game changer, doesn't it? Like the next gold rush is happening not in some remote river, but right under a microscope.
Okay, but let's get real for a second. Beyond the crazy headlines, what are we really talking about here? If we can truly manufacture gold, does that mean the gold chain you own or the ring on your finger is suddenly going to be worthless? We're going to break it all down. What's actually possible, what's practical, and what this all really means for you.
To really get to the bottom of this, we've got to start with a little bit of fundamental science. Because, and this is crucial, making gold is absolutely nothing like making its glittery cousin, the diamond.
And this is the absolute key difference right here. See, lab-grown diamonds are a real thing. And they're relatively easy to make because they're just carbon, a super common element. You take carbon, you squeeze it under immense heat and pressure, and you're basically just rearranging the atoms into a new shape. But gold? Oh, gold is a whole different ballgame. It's an element, atomic number 79. To make it, you can't just shuffle atoms around. You have to fundamentally change the identity of an atom from one element into another.
And that's really the heart of it, isn't it? An element is defined by one thing, the number of protons in its nucleus. You can't change that with chemistry, mixing things in a beaker or adding pressure. To change the proton count, you have to go nuclear.
That's right. That ancient dream of the alchemists, it's actually come true. Not through some magical spell, but through the absolutely mind-bending power of nuclear physics. The process is called transmutation, and it happens inside some of the most complex and powerful machines ever built by humankind.
Okay, so how on earth does this actually work? Well, in theory, it's kind of straightforward. Scientists take a very specific type of mercury, an isotope called mercury-198, and they blast it with a beam of neutrons from a fusion reaction. The mercury atom catches a neutron, which makes it unstable. And then, over the next 64 hours or so, that unstable atom naturally decays and turns into stable, 100% real gold. It's a proven process. So that's it, right? We can make gold? Well, not so fast.
Just because something is scientifically possible, that doesn't mean it makes any sense in the real world. And this is where the alchemist's beautiful dream slams right into a very, very harsh reality check.
First up, the price of admission. To even try this, you need a fusion reactor. The estimated price tag to build just one of these experimental facilities? We're talking a cool $5 billion. And what do you get for your $5 billion investment? Well, one of these reactors could pump out about 5 tons of gold a year. Now, 5 tons sounds like a lot, right? But then you look at the big picture. Globally, we mine about 4,000 tons every year. So that brand new multi-billion-dollar machine adds just a tiny drop in the bucket, 1/8 of 1% to the world's supply.
But honestly, here's the real kicker. The process doesn't just make the stable gold we all know and love. It creates a mix of different gold isotopes. And yep, some of them are radioactive. So before you can even think about selling this new gold, it has to sit in a secure facility while it cools down. And the waiting period? Get this, almost 2 decades, 18 years.
And, someone on Reddit just nailed it perfectly with this comment. You get your gold, sure, but it comes with a, shall we say, an atomic complication. Not exactly what you want in your wedding ring or your investment portfolio.
So let's just recap, because this is kind of nuts. You've got an astronomical upfront cost, a laughably small output, you have to wait 18 years for your slightly radioactive product, and this whole thing depends on experimental fusion tech that hasn't even proven it can generate more power than it consumes. The bottom line? It costs way, way more to make the gold than the gold itself is even worth.
All right, so it's pretty clear that commercial lab-grown gold is, well, it's a total non-starter right now. But let's imagine a future, maybe decades from now, where the tech gets way better. How would the market react? Well, we can get a sneak peek by looking at a real-world example that's playing out as we speak.
I'm talking about lab-grown diamonds. I mean, these have gone from being some weird science experiment to a huge player in the jewelry world. And they give us a fascinating look at how a synthetic version can go head-to-head with a traditional, deeply valued commodity. Think about it. In just a few years, lab-grown diamonds have snatched up a whopping 15% of the global diamond market. That's huge. It proves that under the right circumstances, people are totally willing to buy a lab-made alternative. So what were those circumstances?
Well, it really boils down to 4 big things. 1, they were way cheaper. 2, they appealed to younger buyers who care a lot about ethical sourcing and sustainability. 3, the marketing was brilliant. And 4, this one is critical, government stepped in with clear rules about how to label them, which built trust with consumers.
But here's the thing. When you try to apply that same checklist to gold, yeah, the whole argument just completely falls apart. Chemically, sure, it's identical. But on every other point, lab-grown gold is way more expensive. It has zero established resale market, and it completely lacks the thousands of years of cultural history that makes natural gold a trusted way to store wealth.
So you're probably thinking, okay, if making gold is so pointless, why are we even talking about this? And that is a great question, because the real story here, the truly revolutionary part, isn't about gold at all. It's about the technology that makes it possible.
I want you to just forget about the gold for a minute. The real breakthrough we're talking about is fusion energy. We're talking about capturing the power of the sun right here on Earth. If we can perfect that, it would mean a future with near-limitless clean energy for everyone.
And when you think about it that way, making a little bit of gold is, well, it's just a party trick, right? It's a cool proof of concept. The real prize is an energy source so powerful it could totally reshape our civilization, from manufacturing and clean water to powering missions to Mars. That's the revolution.
All right, so let's boil this all down. What do you need to remember? First, yes, we can technically make gold. It's real science, but it is nowhere near practical or economical. Second, that gold rush under a microscope is still decades away, if it ever happens at all. So the next time you see a wild headline about a new breakthrough, just ask yourself, what's the cost? What's the scale? And what's the real timeline? Because the shiny object isn't the story. The real revolution to watch is the fusion technology behind it. And all of this leaves us with one really big question to chew on. For all of human history, gold has been valuable because it's rare. But if we enter an age of abundance, thanks to technologies like fusion, where we can potentially create whatever materials we need, what does that do to our whole idea of value? In a world where scarcity might not be the rule anymore, what's the stuff we will actually cherish?
Yeah, something to think about for sure. Thanks for joining me for this explainer.